Hello, I'm Cal Wellborn, acarologist with the Florida Department of Agriculture and Consumer Services, Division of Plant Industry in Gainesville, Florida. We've now keyed out this mite to the Penthaliedae, or Eupodoidea, most likely Penthaliedae, and now we're going to continue on and key it to genus. We're going to start with a character that identifies it as Eupodoidea, which is the recumbent Solnidia with the stellate famulus, usually at the proximal end of this trough with the recumbent Solnidia. In some groups, this moves along the trough, but it's always there associated with the recumbent Solnidia. So it has a recumbent Solnidia and the stellate-shaped famulus. Now we'll look at the whether it has a naso or not. I'm going to go to a different power. All right, now I'm at 40x. I'm back looking at the prodorsum. Eunathosome up here, leg 1 over here. This round structure is at the anterior end of the prodorsum. This is the naso. This has your VI-CD. These may be Trichobothria or not. Sometimes it's hard to tell with the CD on the naso, but we did see prodorsal Trichobothria when we keyed this out to family. So it is a Eupodoid. I'm going to move on to couplet 2. Adults well sclerotized, dorsum idiosome ornamented with a pentagonal pattern and a distinctive Y-shaped furrow or sclerotized anterior projection extending over the gnathosoma, usually bearing CD. All right. We can see, just looking at the rest of the prodorsum here, here's your prodorsal Trichobothria again. So your prodorsum ends about there. If we move back to the opistosoma, this is an internal structure. This is actually the sperm sac. This tells me it's a male. All Eupodoid males have some sort of a sclerotized structure that looks like this. All Eupodoids have this sclerotized structure if it's a male. So that has nothing to do with being sclerotized on the surface. But we can see this mite is pretty soft. There's no sclerotization. There's definitely no V or Y-shaped furrow or a sclerotized anterior projection. So we're going to go with couplet B, body weakly sclerotized, unornamented, without a Y or V-shaped furrow or sclerotized projection. Cupules, circular, if we could see them. Cupules in a mite like this that is neotrichous, cupules are almost impossible to find. If you were lucky enough to have a really good specimen, you might find them. But it's unlikely we'll see them in this specimen. So we're going to just have to go without the cupules because we can't see them. So go on to couplet 3. Naso large with more than 20 CD, subcapitulum with 12 to 15 CD, 4 pairs of adorals, distal and a small. Basically what we're saying is naso with 20 or more CD, subcapitulum with 15 pairs. Of those, there are 4 adorals that are small and 2 large basal pair. Palptibia with at least 6 CD. This is only known from Australia. There are 5 species known, and we believe these are plant feeders. The other option is naso small with 1 pair of CD, maybe Trichobothria, subcapitulum with not more than 4 pairs of CD and 2 pairs of adorals. Palptibia with 3 CD. So let's look at the naso first. And we just looked at that before. And here's the naso, just 1 pair of CD. Subcapitulum, a little hard to see on this specimen, but okay, here we go. Subcapitulum with not more than 4 pairs of CD and 2 pairs of adorals. So here are 2 pairs of subcapitular seedae. Here's at least one adoral here. Adorals tend to be very small, easily missed, especially if you're not at oil immersion. But there's definitely not, in this specimen, there's definitely not 12 to 15 pairs of seedae on the subcapitulum of this specimen. So we'll go with, we'll eliminate Ariorhynchidae and move on to couplet 4. Intercoxal regions, legs 1 to 4 with more than 15 pairs of seedae. Anal opening dorsal or dorsal terminal. So we're going to move to the coxal region. And you need to make sure you're looking at the ventral surface of the mite. This particular mite is hypertrichous, so there's lots of dorsal seedae, lots of ventral seedae. At this point, we're ventral. This is coxa 2. There's some seedae on the coxal region. These are all ventral idiosomal seedae. I think we're safe to say there's more than 15 pairs of seedae on the ventral idiosoma here between the coxal regions. Now we want to look for the anal opening. In these mites, in prostigmata, the anal opening can be ventral, which is normal, usually just behind the genital region. In some groups, it may be terminal. There's at the back of the mite, and in a few cases, it's dorsal. So we want to determine where the anal opening is in this mite. The best way to do that is you find the genital region and then work from there. As I said, this is the sperm sac of the male. This is internal. All right, here's the genital opening. These are the genital valves here. And these seedae down in here, there's, you can see 2 of them, and there's a couple others down here. These are what are called eugenital seedae. These are actually inside the genital opening. They're not on the surface. The seedae on the genital valves are these seedae here and here. And these are all genital seedae. So now that we have the genital opening, we'll move posterior to find the anus. This is where it can be tricky. You want to make sure you're looking at dorsal ventral. And there's nothing obvious immediately posterior to the genital region. We move. All right, here's the back of the mite, the back of the idiosoma. There's nothing obvious between here and the genital region. So now we're going to focus on the dorsal surface. And it can be difficult. What you want to do is you want to find something you know is dorsal and then work from there. All right, we know this is ventral, this is the genital region, so we want to focus on the dorsal surface. All right. Now we're over the genital region, but we're now focused on the dorsal surface. And right here is the anus. The anus is dorsal. In some cases, it's more obvious that this is the anus. Sometimes there's a big flange around it. So it varies, but this is the dorsal anus, right here of Penthaliedae. So we're at couplet 5. We have a dorsal anus, palp femur genu with more than 3 seedae. We'll have to look at that. And the body seedae, ventral body seedae are smooth. And we're back to the ventral surface now. There's the genital region. And you can see these seedae are smooth. So the ventral seedae are smooth. This is dorsal. This is dorsal anus. This is ventral, genital region. Now we're going to look at the palp femur genu to see how many seedae are there. Palp tarsus tibia, this is the femur genu. And according to the couplet, there should be at least 3 seedae here. There's 1, 2, 3, 4. So there's more than 3. When you're looking at a particular segment, whether it be the palp or whatever, where you have to count CD, you want to focus up and down to make sure you get all of it. Sometimes these CD can be broken. So what you look for is the base of the CETA. Or a CETA can be broken off the leg or someplace else and drifted over there during mounting. So you don't count them unless you can actually see a base. In this case, all the CD are there. 1, 2, and then we go to the other side, 3, and 4. So the anus is dorsal, the palp femur genu has more than 3 CD. Ventral body CD are smooth, so we move on to couplet 6. And couplet 6 is tarsus leg 3 without recumbent solenidia. Fixed digit, 3-tined, palps short and stout. Since we're looking at the palps here, we can see the palps are not short and stout. That's tarsus, tibia, femur genu, trochanter down there. So now the other character is fixed digit, 3-tined. Here's your movable digit. This is your fixed digit here. It's got what appears to be a CETA on the tip of it. It's definitely not 3-tined. Your movable digit, your fixed digit here. So it's not 3-tined. Now we're going to look at tarsus leg 3 to see if there's any recumbent solenidia. We're at the distal end of tarsus leg 3. Focus up and down. This is the ventral side of the tarsus. These cetules on these CD are usually typical of ventral CD on tarsus. This is dorsal. In most cases, specialized CD like famulus, microceta K, solenidia, Eupodoidea are normally dorsal. You're not going to find many of them on the ventral side. There are a few exceptions, but so you want to look at the dorsal surface of the leg segments when you're looking for special CD, dorsal and maybe somewhat lateral if the specimen got rolled while it was mounted. So this is ventral, this is dorsal. Nothing obvious here. Move down the segment. Ventral, dorsal, ventral, dorsal. Now you're not always going to be so lucky as to have a segment that's mounted dorsal ventral like this. Most of the time you're going to be getting a lateral view, but you can tell which one's dorsal ventral by the type of CD. And there's no solenidia at all that I can see on here, no recumbent solenidia on leg 3. So we move on to couplet 7. Now we're looking at legs 1 to 4, whether longer than the body, and then leg 1, and sometimes 4 if it's twice the length of the body. We're going to go to a lower magnification. All right, we're at 5x now. And ideally you would have an ocular micrometer so you can measure the distance roughly. But we can eyeball it here and see that you can see the whole idiosoma in this view. Gnathosoma here is back of the idiosoma. And if we go to leg 1, okay, leg 1 is slightly longer than the body, but it's not 2 times the length of the body. So we come up with Penthaliedae. The genera in the Penthaliedae, other than Penthaleus and Haloteideus, those are the only 2 we know that are major pests. Haloteideus is Australia, South Africa. It's a pest in Australia, but not in South Africa. Those species are not known in the US. In Florida, we've intercepted Haloteideus twice since I've been there, and we've picked Penthaliedae up occasionally. In Maryland, Virginia, several years ago, a Penthaliedae turned out to be a major pest of bok choy, and some of those winter crops. But it had not been seen in many, many years.